Good afternoon. In this short video, we're going to do a revision of the main points of linear motion. That's motion in a straight line. By the end of this video, you should be able to do the following. You should be able to explain the difference between the term displacement and distance. You should be able to define speed, define velocity, and define acceleration. They'll all really be labeled formulas. You should know what is meant by the term acceleration due to gravity, or small g as we often call it. You should know where you can find the three equations of motion in the maths tables, and you should be able to do a few little short questions on these equations. And at the end of the video, you can use this as a checklist to see if you've achieved these objectives or not. The terms distance and displacement are very similar, but there's a subtle difference between them. Distance is simply the space between two things. That's hardly even a definition, and we measure distance in meters. Whereas displacement is the distance between two objects in a certain direction. So this is the big difference between displacement and distance. Displacement has a certain direction, distance doesn't. They're both measured in the units called meters. You probably have come across the idea of speed many times, and speed is simply distance divided by time. You can say it's the rate of change of distance with respect to time, but I think the formula distance over time is one that most people are familiar with. The units of speed are meters per second. We can write it meters/seconds, or the more common, the more modern way is to write it meters seconds minus 1. Speed is distance over time. Most of you are familiar with that. The word velocity, of course, is very similar to speed, but in velocity, we know the direction something is moving. So a good definition of velocity is that velocity is speed in a given direction. Another definition is velocity is the rate of change of displacement with respect to time, or you can use a formula, velocity is displacement over time. But again, the first definition there, speed in a given direction is velocity, is perfect. The units of velocity are the same as the units of speed, meters per second or meters seconds minus 1, whichever way you care to write it. The idea of acceleration is very easy. Acceleration is something happens when an object changes its velocity. We have a nice cheetah. The cheetah is still. The cheetah at this stage is moving. The cheetah has changed its velocity between these 2 points, and acceleration is something that happens when the velocity of an object changes. That, of course, is not a definition of acceleration. The more common definition of acceleration is here. Acceleration is the rate of change of velocity with respect to time. How quickly your velocity is changing per second. And most people define acceleration with a formula, and the formula is acceleration is the change in velocity divided by the time taken. Or if we have an object that is starting with a velocity of u, ending with a velocity of v, then v minus u is the change in velocity. Divide that by the time taken, we have the acceleration. So that formula is the one that most students in Leaving Cert use to define acceleration. Of course, if you use a formula to define something, you have to label it. So acceleration is the change in velocity, final velocity minus starting velocity divided by time taken. Or if you want to put it in words, acceleration is the rate of change of velocity with respect to time. The units of velocity are different than the units of time. The units of acceleration are different than the units of velocity. The units of acceleration are meters per second squared, or meters seconds minus 2, and it's very important to know that that's different than meters per second minus 1. And a quick example question, and it's an easy enough one, on the concept of velocity and acceleration. Example question, define velocity. Well, velocity is the rate of change of displacement with respect to time, or you can say velocity is speed in a given direction. That's perfectly acceptable as well. What is acceleration? Acceleration is the rate of change of velocity with respect to time, or you can give this formula and of course label it as we've just seen previously. Acceleration is final velocity minus initial velocity over time taken. The rest of the question is quite interesting. It says the cheetah is one of the fastest land animals. A cheetah can go from a velocity of 28 meters per second. Can go from rest, which of course rest would imply 0 meters per second, up to a velocity of 28 meters per second in just 4 seconds, and stay running at this velocity of 28 meters per second for a further 10 seconds. while it chases something. Sketch a velocity time graph to show the variation of velocity with time for these total of 14 seconds. So we'll do that. It's a sketch graph. You might think that line is crooked, but it's actually my camera. And a sketch graph doesn't have to be a work of art, but it has to be functional. So I'm going to put here VE, velocity in meters per second there, time in seconds on that axis. Even in a sketch graph, we have to put our quantity and our appropriate units. It said 1, 2, 3, 4 seconds, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Another 10 seconds to bring us to 14 seconds. There is 0 meters per second, and our Cheetah can go up to a velocity of 28 meters per second, and it does that in 4 seconds. So it accelerates up like that, and then it stays doing that for a further 10 seconds. So this basically is our velocity against time graph to describe the motion of that Cheetah. Okay. The next part is interesting. Calculate the acceleration of the Cheetah during the first 4 seconds. Now, this is where I write down my everything I know. U-V-A-S-T. Write down everything we know. Well, we said the Cheetah starts with a velocity. It starts from rest, so its initial velocity is 0 meters per second. It goes up to a final velocity of 28 meters per second. We were told that in the question, and we're asked to find the acceleration. The distance it travels, we don't know and we're not asked about, and we're told the time is 4 seconds. So the initial velocity, 0 meters per second. The final velocity, 28 meters per second, I got from the question. The acceleration is what we're looking for, so that's what we're looking for, and the time we were told was 4 seconds. So I can then write down my formula. Acceleration is v minus u over t. That's a formula that's used as definition of acceleration. V is 28 minus u is 0 over the time 4, which is 28 minus 0 is 28, divided by 4 is 7. 7.0, but we must put the appropriate units of acceleration there. So it's meters seconds minus 2. As always with answers, I like to just put a little red line underneath them like that. And so we have calculated the acceleration of our Cheetah, and it's 7.0 meters per second. That means every second, each of those 4 seconds that the Cheetah is moving, it's gaining 7.0 meters per second. So after 0 seconds, its velocity is 0. 1 second, it's 7 meters per second. 2 seconds, it's 14. 3 seconds, it's 21. And after 4 seconds, its velocity is up to 28. It can no longer accelerate more than that, but it keeps that velocity for some considerable distance. Okay, the next thing on my list was acceleration due to gravity. By the way, that's so important, it's given its own symbol, small g. Now, we all know that if you drop something, it falls. But we also must appreciate that if you drop something in a gravitational field on or near a planet, not only will it fall downwards, but it will get faster the more it falls. The greater the distance, the greater the time it is falling, the faster the object will get. Now, that means it's accelerating. The acceleration is known as the acceleration due to gravity. And in simple terms, it's the rate that an object in free fall, falling without any resistance, an object in free fall gains velocity. Now on Earth, we have measured that an object in free fall will gain on average about 9.8 meters per second of extra velocity for every 1 second that it's falling. That means if you drop an object and time it and measure its velocity at the same time, after 0 seconds it will have gone, its velocity will be 0 meters per second. 1 second later, it will have accelerated up to 9.8 meters per second. Another second, it adds on another 9.8 up to 19.6 meters per second. And after 3 seconds, it will accelerate up to a velocity of 29.4 meters per second. In other words, it's gaining 9.8 meters per second of velocity for each of those seconds and will continue to do so. Air resistance, of course, will slow it down. We're assuming a vacuum in these conditions or in this particular thing. So Acceleration due to gravity is the rate at which an object in free fall will gain velocity, and most people would remember that its value on the surface of the Earth is 9.8 meters per second. So we actually write it like this: G equals 9.8 meters per second, or 9.8 meters seconds to the minus 2. The three equations of motion are very important equations that link together an object's starting velocity, final velocity, acceleration, the time it takes to go from those points, and the distance it travels. They are all there on the maths tables on page 50 of our maths tables, and we've got v equals u plus at, the final velocity equals initial velocity plus acceleration by time, distance equals the distance something travels, or the displacement, is the initial velocity by the time plus a half acceleration by time squared, and the final velocity squared equals the initial velocity squared plus twice the acceleration multiplied by the distance. They're always there if you need them, and of course you'll have this maths tables in your exam. And here again I've just written out our three equations of motion, and of course it's very, very important to know which one to use in any given question. So what we tend to do, we follow a certain pattern in these questions. We identify what we've got, and then we see which formula will fit our problem. So what we're going to do is look at a couple of example questions that have come up in the Leaving Cert Honours paper over the years. Okay, we'll look at the first one. What is the shortest stopping time? So we're looking for time for a car, which, and of course it's stopping, that means it comes to rest, so its final velocity will be 0. The initial velocity of the car is 16 meters per second, and it has a deceleration, negative acceleration of 2.5 meters per second. I always write down this: U, V, A, S, T. U, initial velocity; V, final velocity; A, acceleration; S, the distance traveled, which of course is also the displacement; and T is the time. So let's fill in all of these, and we'll see what we've got and where we can go after that. Well, the starting velocity of the car is 16 meters per second, so we'll leave that there. The car stops, it comes to rest, so its final velocity is 0. We're told the acceleration is 2.5, but it's deceleration. The car is slowing down, so we denote that by putting a minus there. And we want the shortest stopping time, so we're really looking for the time. The distance the car travels and that length of time we're not really that interested in. So the question now is, which of my formulas here will work? Well, I've got U, V, and A, and I want T. I've got U, V, and A, and I want T. I've got U, V, and A, and I want T. So that formula won't work because there's no T in it, but this formula of course will give me S if I want it. I've got U, V, and A, and I want T. So it looks like that guy is my formula there. So we'll write down the formula. V equals U plus AT. We're looking for the T, so we just fill things in. Always write your formula first, then fill things in afterwards. The final velocity of the car is 0. The initial velocity is 16 plus minus 2.5 is the acceleration. I'll put that in brackets for a moment by T. We've done the physics at this stage. You've got 2/3 of your marks. Now the rest of it, of course, is maths. So I'm going to say 0 equals 16 minus 2.5 by T. I just multiplied in the minus. Bring the 16 over, it becomes minus 16 equals minus 2.5 the time. There's minuses there, so they can cancel off. We can cancel off the minus there and there. We bring the 2.5 over, so 16 over 2.5 equals the time. And using a calculator, I think 16 divided by 2.5 will be 6.4 seconds. I like my answer there, so I underline it in red. And the second question, the second short question, comes from the 2011 Leaving Cert Honours paper. It's a slightly different version of that, changed it ever so slightly. We'll have a look at it. It says a car is travelling with a constant velocity of 20 meters per second. That's its initial velocity. Calculate the acceleration needed to stop the car. That means its final velocity will be 0 in a distance of 50 meters. I use my standard U, V, A, S, and T, and I'll see which of these I have, which I don't have, and which I need. Well, the starting velocity of the car is 20 meters per second. The car stops, so its final velocity is 0 meters per second. The acceleration is what, of course, the question we're looking for. and the distance the car travels in that time is 50 meters. We don't know the time taken there, and we may not need it in our question. So the question again is, which of the formulas works there? And since we have U, V, and A, and we're looking, U, V, and S, and we're looking for the distance, then I suggest the third formula there is the one. V squared equals U squared plus 2AS. So V is 0 squared equals the initial velocity 20 squared plus 2 times the acceleration that we're looking for by the distance the car travels, 50 meters. Always write your formula first, then the substitution in, then you do your mathematics. So we'll do this. 0 squared is 0. 20 squared is 400. Plus 2 by 50 is 100 times acceleration. Bring over the 400. It becomes minus 400 equals 100 times acceleration. Divide each side of the equation by 100. They cancel. So we've left with acceleration equals minus 400 over 100, which is minus 4.0. The units of acceleration are, of course, very important. Meters per second minus 2. Of course, we knew it had to be a negative answer. We knew the acceleration had to be negative because quite clearly the car is going from 20 to 0. The car is slowing down. The car is deaccelerating. So acceleration, of course, will be negative. So to go back at the end and just look at our little checklist, we looked at what distance was, and more important, we looked at the definition of displacement. We said speed was distance divided by time, velocity was speed in a given direction, and we said acceleration was the rate of change of velocity with respect to time. We had a look at acceleration due to gravity, and we said that is the rate that velocity is gained by an object in free fall. We looked at page 50 of the maths tables where the three equations were, and we looked at a couple of easy enough examples on those three equations of motion. Your job now is to go back through this checklist and just make sure you know all those definitions. Okay, this has been a very quick class and maybe not a very good one, but it gives you something to do. Thank you very much.